Okay, so today we're going to review for our third and final benchmark of the year. I'm going to count this as a classwork grade, and it's just topics from basically the whole year. So here we go. I'm going to do most of them with you, but I am going to not do all of them. So what I don't complete, well, you're going to have to do the entire benchmark on Encourse, but just so you know, I'm not doing all of these with you. I'm going to skip some. So you can do some on your own for practice. So you don't have to take any notes today. You don't have to print this out. You just have to go on to click the link, put in your codes like always, and do the benchmark with me. You might want to have it up while you're watching the video, or if not, write some notes down. I don't know, but no notes to submit to me today. All right. First, we're going to graph this function, use the line tool. So you have to use the tool that's on the computer. I'm just going to graph it on the paper, obviously. So we're going to start off with, this is a linear function. It's a line. The y-intercept is 2, so I'm going to go up 2. And then the slope is negative 1/3, so I'm going to go down 1, right 1, 2, 3. I can go in the opposite direction and connect the dots. And there's my line. Next, negative 2/3 x minus 6, same thing, we're going to graph. Oh, actually no, do this one on your own. Do this one on your own, easy enough. Okay, this one. So this one, which best represents the graph of f of x equals negative x squared plus 3x plus 4. So it's a parabola. How we could figure this out is we could figure out what our vertex is for this by doing x equals negative b over 2a. That should ring a bell, hopefully. So x equals, b is 3, so negative b is negative 3, over 2 times a, which is negative 1. So x equals positive 3/2. Negative over negative is a positive. So x equals 1.5 if you change that to a decimal. So I know that this is not right because that says negative 1.5. I have to go on to the next page for some of my other choices. I know that this one's not right. So right now my choices are either this one or this one. So I have to figure out what my y value is. To do that, I'm going to plug back in. So f of 1.5 equals negative 1.5 squared plus 3 times 1.5 plus 4. Okay, so f of 1.5 equals 1.5 squared is 2.25 and then negative, so negative 2.25 plus 4.5 plus 4. F of 1.5 equals negative 2.25 plus 4.45 plus 4 is 6.25. So our vertex should be 1.5, 6.25, so not that one. So this is the correct answer. That has that vertex. You can also graph, remember the y-intercept. The y-intercept is c. Like if it asks you to graph something like this, this is the y-intercept, 4. So that's another thing to look for. This one you can follow your pattern of down 1 over 1, down 3 over 1. Okay. Next, do this one on your own. Same thing, negative b over 2a. Okay, this one. 3 functions, 1 linear, 1 quadratic, 1 exponential are graphed below. As the value of x gets larger and larger, which of these functions will eventually have the largest value? Okay, so for this, I can see that my linear function is b, because it's going, no, that's not right, sorry. My linear function is a. B almost looks linear, it's kind of tricky. So linear is a, that's a line. This one is my parabola, c, so that's my quadratic. And then b is my exponential, which is kind of hard to see on this, but if you look at it, it looks like it's kind of going straight, but it's not, because it's kind of like curving. And then it's going to start curving faster and faster and faster and faster, and it's going to go up like that, okay? Exponential functions, they approach infinity the fastest, always. Compared to any other functions, exponential functions always approach infinity the fastest. So function b, because function b is an exponential function. Okay. Next, if we look at this one, which of these following functions has the greatest values of y as x approaches infinity? We have a linear. We didn't even learn about that. You'll learn about that in algebra 2. This is your exponential right here because it's 2 to the x. This is a parabola. On the other side, it'll go up like that. Okay, so it's that one. That one's going to approach infinity the fastest. Try this one on your own. Okay, this one. Which graph represents g of x equals the cube root of x plus 8? So this plus 8 tells me that it's moved left 8 units. Okay, so I want to look at which one's moved left 8 units. So this one's certainly not. This one's moved up 8. This one looks like it's moved left 8. That's the center point, right? Let's just check the other ones. Nope, this one's moved right 8, and this one's moved down 8. So it's definitely this one, left 8 units. Not that one, not that, not that. All right, next. Assume that f of x equals negative 2 to the x plus 4. Constant k is added to f of x, resulting in the graph of f of x plus k below. What effect did k have on the graph of f of x? So here's a function that will be an exponential moved up 4 units. This is an exponential moved down, looks like about down 4. That's what it looks like to me, because that's negative 5, so about down 4 units. So it's going from positive 4 all the way down to negative 4. So it shifted the graph in a negative vertical direction. It stretched the graph in a vertical direction, it stretched the graph in a horizontal direction, or it shifted the graph in a negative horizontal direction. Well, it was a negative direction and it went down, so that's vertical. So negative vertical direction, this one. Might be in a different order on your screen, not sure. Okay, this one you should be able to do on your own. You just have to count the units, how much it was moved down. This one you should be able to do on your own. You got this function, moved up 1. This one's up 4. You can figure that out. This one, which expression shows the solutions to the equation 2x squared plus 9x minus 9 equals 5? Okay, so for this one, what we need to do is we need to do quadratic formula. So I'm going to move over the 5. So now I have 2x squared plus 9x minus 14 equals 0. Now I can apply the quadratic formula, which is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. That's quadratic formula. Make sure you write this down somewhere so you have it for tomorrow, okay? I mean, it's in your notes from, I don't know, a couple weeks ago or something, but have this down because you're going to need this for your benchmark tomorrow. Okay, so x equals, the opposite of b is negative 9, plus or minus the square root of 9 squared minus 4ac, so that's 2 times negative 9, over 2 times 2. Okay, so now we're going to have to start simplifying. So x equals negative 9 plus or minus square root of 81. I was noticing a lot of mistakes with this when we learned this. We have a negative number and a negative number and a positive number. So we have negative, so negative 4 times 2 is negative 8 times negative 9. Oh my goodness. I messed this up because you know why? because C is actually not 9, it's actually negative 14. I'm sorry about that. I'm looking at the original, I'm not looking at this. This is what you should be looking at. I'm sorry. Okay, back on track. Everything else is plugged in right. Okay, so negative 4 times 2 is a negative number, times another negative number is going to be positive. Be careful with your negatives. And that's going to be positive 112 over 4. So now x equals negative 9 plus or minus the square root. 81 plus 112 is 193 over 4, and that matches with this one. Okay. I would like you to do this one on your own, quadratic formula again. This one, it asks about the zeros. So we can definitely factor this. Just by looking at the solutions, I could tell that it's factorable. This one I knew it wasn't because of the square root, the radicals in here. So this, to factor this, we're going to have to slide and divide. So f of x equals x squared plus 11x minus 12. The next step is to factor. So it factors to 12 and 1, positive 12 and negative 1. So x plus 12 and x minus 1. Then we have to divide by what we originally slid by. This is the most common mistake I've been seeing, is you're forgetting to divide. Divide by 3, divide by 3. Now we have x minus 1/3, and we have x plus 4. We need to set both of those equal to 0. So x minus 1/3 equals 0, and then x plus 4 equals 0. So for this one, you add 1/3 over, add 1/3, and you get x equals 1/3. For this one, you subtract 4, x equals negative 4. So those are your two answers. So negative 4 and positive 1/3 is this one. Okay. This one, you just factor regularly. This one you should be able to figure out on your own. Just be careful with your negatives with that. So this one you just factor regular. You don't have to slide and divide. So you just go like this, and you say, what two numbers multiply to 24 and add to negative 10? Be careful, it's not 12 and 2. Okay, do that one on your own. Next, this one. What are the zeros? Slide and divide for this one. Do this one on your own. For this one, this is slide and divide again. This one's slightly trickier though because we have a negative in the front. So let's do this one together. So we're first going to slide over this negative 6 and multiply it by the 15. So now we have x squared plus x minus 90. Now to factor that, it's going to factor to x plus 10 and x minus 9. I'm going to divide by negative 6 because that's what I slid by. Now I have to reduce these fractions. So now I have x, this is a negative now, so x minus, and then I can divide both by 2, so 5/3. And then for this one, negative over negative is a positive, so it's x plus. I can divide both by 3, so 3/2. Now I set both of these equal to 0, so x minus 5/3 equals 0, and x plus 3/2 equals 0. So you have add 5/3, x equals 5/3, and then x equals negative 3/2. So positive 5/3 and negative 3/2 is this one. Okay, this one, you're going to use this and you're going to do negative b over 2a. So I'm just going to guide you a little bit on this one. X equals negative b over 2a. And then you're going to look for the vertex. So you're going to find what x is, plug back in to find what y is, and then just look for which one has that same vertex that you found. Okay? find x, plug back in, find y, and then pick the correct answer. All right. Simplifying radicals. We haven't done this in a while, so let's just go over that. Square root of 24. You have to think what perfect square goes into 24. That would be 4, so I can simplify this to 4 times 6. And the square root of 4 is 2, so it's 2 radical 6. This one you can do on your own. This last one, we have to simplify all these things. So first, we're going to simplify radical 24. We just did that before. So for this one, I'm going to move this up a little bit because you can't really see. Oh, I printed out twice. That's why it's so thick. Okay. Whoops. That's a waste of paper. Okay. So square root of 4 times 6. For this one, I can simplify it to 9 times 2 because that's the perfect square that goes into radical 18. And then I can't simplify radical 6, so I'm just going to keep it as radical 6. So now radical 4 times 6 is 2 radical 6 minus radical 9 times 2, that would be 3 radical 2 plus radical 6. And then the last step is to combine like terms. So 2 radical 6 plus radical 6, technically a 1 radical 6, 2 radical 6 plus 1 radical 6 is 3 radical 6 minus 3 radical 2. Can't combine these. So that's the answer, which is this one. Okay, that is it. So you have to do the rest of these. Well, you have to complete the entire assessment. Make sure you go through and do the ones that we skipped and submit your assessment online. All right, have a good day.